In this Christmas special video, I have an interesting and fun topic for you if you're a user of the Neo4J database. So what we're going to do today is how to implement an undo feature. So as you've probably seen this year, I've produced some content on how to use Neo4j, especially with a Quarkus application. And what I've done in a side project and what I can share is how to do an undo feature in an enterprise application. So naively, this from a user perspective sounds rather easy, right? You just do an action and then you undo it again. But as you know, when using a database, this can actually be very tricky for undoing data that don't exist anymore. So what we will do is to have a look at an example that is somewhat similar to what I showed in this video back then, is how to run an application that uses a Neo4j database, is to have our coffee shop example that we're going to enhance with some undo features. So for example, if you maybe remember this example, or you also can have a look at it, it's basically some coffee beans that contain some data, for example, where a bean origin comes from or what the bean tastes like. So we have something like a flavor profile that's stored in our graph. And now imagine that we would like to change something here. Maybe there's an update, a new batch of a specific bean or something like that. And then in this case, we would like to, undo a change. So for example, in applications, that's very helpful to offer the user something that they did just per accident, or if there was a deletion per accident, to restore some data. So now imagine if we have a node that would be deleted and then we restore it again, or that's even more tricky if we have relations that change. So this arrow, for example, changes to another node, then we need to undo that change, or if that relation also has properties, well, then the same. And what I came across is this plugin, or basically this technology for Neo4J Streams, which is an integration into the Neo database itself that publishes changes that have been made in certain transaction to a Kafka. And in this case, actually the implementation that we're going to use, we don't care about Kafka, but since this uses a CDC, a change data capture approach, this is actually also the key to how we will implement our undo feature and what we will do. So first of all, what I would like to show you is the integration in the application, how we actually make sure that we have something like an undo feature. And basically what we do from a perspective is that we save what happens within a certain transaction, including the multiple statements in a query. For example, update some node and maybe update some relationship, create a new relationship and delete the old one and things like that, to basically undo, to do the negation of all of that, what happens, and apply that again. And how this works is that we can use the so-called change data capture and persist it, ideally in our same database, because that works quite well. What we do for this matter, I show you this Quarkus application. So this is the Quarkus playground for our coffee example, and I've enhanced this with a few more actions where we can actually update or delete some coffee bean. So we have the creation, and we can return some bean, for example. And also, now we can update. In this case, I'm interested particularly in the flavor profiles. What that looks like is my application is already running in this Quarkus development mode. So I can, for example, query my local host 8080, the coffee beans that I have. And then I see, if you remember the previous examples, I have a so-called flavor profile, which is a weighted flavors for percentage-based flavors that add up to 100%. And we can update this. So for example, if I would like to create a new coffee bean, so for example, I'd like to, it's already the undo, then we have some example here, post a new bean that I call, for example, my bean, something like this. And that has a specific origin, a roast, and flavor profiles. So this is basically what I would like to create, and I can do that. That is just a basic action. when then my bean will be created, and I hopefully can also access this data by just querying the name of my bean. And then it tells me the flavor profile, so much fruity taste, floral taste, and all of that. And now what I can do in my application, I can actually update these flavor profiles. I say, well, please, patch this resource. So HTTP patch. I could provide all of the data like a put request and then basically provide this whole JSON. Or I say, well, do just an individual patch of just updating the flavor profile. So for example, I can say, I patch my bean. And then I say, in this case, I just want to change maybe floral to nutty taste or some other taste with now 80% and 20% floral. And then I can update this. And if I now query the bean again, I see the changes here. Okay, well, that's boring. That's just an easy update. But it already tells us some action ID, what that is. Okay, so this is how now we had to enhance our application internally to prepare it for these actions. So actually what we need to do is we need to persist this change somewhere. And what we ideally do is to have some change data capture structure that is actually also part of my database. Why? Because it's the easiest way. I could, of course, use this Neo4J Streams integration to stream it to some Kafka topic and use it somewhere else if I would be interested in all of the events. But in my case, I actually want to have the data in the same database that I can, of course, also use transactions. So what we have in our bean, now the CDI bean, there are a lot of beans here, is that we have our update method that actually returns an action ID. So what it does, my running transaction, my Lambda here, always will just say, well, whatever you do for this particular transaction, the Neo4j transaction, I actually include a generated action ID. And what I have is I also create an action node. So this action node, this is actually a node in the database, and this will contain, well, this change data capture. So how this works is I provide this action ID so that I can query it later on. I provide a timestamp, this might be helpful. And then I can look into my database and see actually what's going on. So here in this case, for example, I see the graph of my coffee beans. This might be a little bit small, but the contents here don't matter. This is just the graph what I have. And I also have two nodes, which is an action. So they're just somewhere in the graph. They don't even have to be connected. It doesn't even make sense to connect them with my actual business entity. This might be a first initial understanding that you have. Well, I could use my business entity and just place it somewhere else. So this was also a first thought that I have how to best implement this. But the point is, if you, for example, would delete a node, or if you would change the relationships, and this is basically the point in graph databases, then it can get really tricky. So the best was to just decouple it from the other nodes. And if I now just query my actions and have a look at the table, I see that actually the action looks as follows. It has an action ID. I can show you this in a greater scale. It has an action ID, a timestamp, and what's interesting, it has some JSON. And the JSON, I will tell you in a second where that comes from, but it basically is some data, which is a change data caption. Let me pretty print this. That has some information of the transactions. And this transaction actually has a few operations, like a few queries, which here is just an operation of create something. And what you create is a payload of, in this case, a node, which is the coffee bean. So yes, this makes sense. This probably was to create my coffee bean action and so on and so forth. It includes some information, some properties with a specific name and roast and all of this. And also there's another operation which created a relationship. So the relationship tastes, which is one of the relationship that we have. Okay, this is the 30% floral taste here. So this is basically the persisted structure of our JSON. But now this is not even the most interesting action. The other interesting action is the one where we now update it. Why? Because this is the action that we would like to undo. undoing a creation action is rather boring because, you know, typically you can easily delete something again. But if you already have something that has been deleted as a user action or changed as a user action where you don't have the previous state anymore, then this becomes more tricky. And this is the reason why we want to have this feature in the first place. So what we have here is we created some bean here, some relationship here, tastes like, with this 20% floral taste, and it probably created another relationship and then deleted the other relationship. So basically this one updates the relationships. What it does, it created one relationship of the nutty and the floral taste, and now I expect that it will delete the other. Yes, here's a deletion statement on the other operations. I expect that it deletes the old relationship. So this is basically what you would write in a query, and this is what happens in our Neo4j query, that then we update all of these things. Okay, interesting. So that is the JSON, the change data capture, where we actually persist. So this is just the representation of what happens in this transaction. We persist what happens and we put it into the node, into the graph. Okay, so this is just the first step. This doesn't really give us an undo action, but it says, well, this is the action in the first place, what happened. So the action here with this ID basically said, please update the relationships, and what's happening in the change data capture is persisted in the JSON. Okay, interesting. Now, let's get a little bit further. I hope you made yourself comfortable with a coffee or a tea or something. Let's go a little bit further and look, first of all, how do we get this JSON? Because if you paid attention in the code, I only have create action, action ID, and timestamp here, nothing else. I don't have the JSON. Why? Well, I actually don't know all of the data. So this is one particular thing. If I would like to undo some actions in my application, I could try to get the current state and the current representation, but this is rather challenging because then I would have to have a few other queries. So what I actually do, this is similar to this Neo4J Streams. This is the reason why I showed you this. We don't use that approach, but a very similar approach of we include a Neo4J plugin that I here open source. This is actually based on the Neo4J Streams, where I removed everything in terms of Kafka and just have a persistent way of storing or updating an action node. So what this is a plugin that runs in the database, and if we have a transaction that actually creates this action node in this one, then this plugin will go and just use the change data capture of all of the other operations in this transaction and persist it to this node in the JSON field. So this looks sounds a little bit weird in the beginning. You can have a look at this code if you're interested. So this is actually written in Kotlin, and what it does, it has an so-called transaction listener, and this listener is pretty cool. It can here, transaction event listener, this is a Neo4j extension. It can look at all of the state that happened before and after the transaction. So with this very easy way, I have access to how the data looked like before. And by doing that, I can persist both before and the after state, which later on I need in order to do my undo. So in this case, I say, okay, what was the before and after, and so on and so forth, and it uses somewhat more complex logic to get all of that data. But what it does at the end, it says, okay, persistent. So it has a certain transaction events. And in my case, what I say, okay, just find if this includes an action node, then please take this node and persist the changes here, which you can see in this merge statement, as JSON. So set the JSON, this is basically the interesting part, of what you have persisted. So it uses all of it, it calculates the change data capture, and then it persists the whole thing to the action node. And this is already running in my database, which you can try out if you give this example a try. There's a shell script that fires up your database, including this plugin. So this is just another Neo4j plugin that you run in your database. And this is the reason why this actually works, why we have this JSON structure here. Okay, so this is already half the rent. Now we have all of these action nodes. Once we have our application actions in my application here with this node, which then will be updated by this plugin. So this plugin looks into certain things like constraints and all of that, and then updates this change data capture, which you can have a look at. Okay, now if this is the case, then I have an action that includes the change data capture for what happens, like not the undo, but the do action, like the forward. Now what I would like to do, I would like to take this action ID that I have here, that this returned in an HTTP header, and say, okay, now please undo this action. And for that, this is now also an interesting part, that's part 2. I have an actions resource, which then could be used, for example, from a front end. So if you have some JavaScript front end, you get some action, you do something, you maybe send an AJAX request, and then you get back the action ID, which you can store. And then if the user says, oh darn, this was just a mistake, I didn't want to update, it was there maybe just by accident, then you can use this feature to send that latest ID, that latest action ID to this resource and say actions undo specific action. Okay, so in this case I can HTTP post this ID back, and what it does, this is now an interesting part, my actions class here goes and first of all tries to load the action, and then you could have some further logic if you say, well, only undo it if it's not later than just a few minutes or whatever. And in this case I would like to have a look at this JSON and basically process and undo it. So I need to first of all just deserialize all of these things, and in this case I have a rather complicated structure of a lot of types that this transaction event, this JSON that I showed you, includes. But basically the interesting thing is the reverse. So I have a transaction reverser that says, okay, in this case, if for example, well, now we need to think what we need to reverse. So if I have, let's say, a creation action, then I would delete it again. Okay, that's rather boring, but if I have a deletion action, that's interesting, then I would need to recreate it based on what was there before. So let's have a look at this case. If I have deleted a node or a relationship, then in this case I want to revert. I want to say, well, please revert the operation. So a delete becomes a create again. So I create that new artifact. And I swap the before and after properties, which is the following. So if before, so for example, if something changed here, if I say before I have something and after I have something else, here in a delete it doesn't make sense because the after is empty, but if it would be a merge, like a change statement, then I say, okay, before and after get swapped. That was there before, now is before, there afterwards again. So it basically undoes it by swapping these two things. And then this basically takes the structure of my JSON and reverses everything. It just makes the opposite, like a git revert, to say, okay, take that div and apply the opposite direction. And then in this case, what it then does, it just, says process the events. So what it does in a transaction, it compiles like a query, and this is now, I think it's somewhere here, process events. This now is another class that basically builds also some logic that I took from this from the Neo4J plugin, and included it in Java, so not in Kotlin because this is a Java project. And then I create some merge statements or delete or creation or whatever they do statements from the data that is there in the JSON. So this actually takes then the data and applies it to my database. So this then really does the application of the undo. Just one side note, this is somewhat a workaround, that in some cases I have to look into the proper types because I use an OJM approach, and then in some cases the JSON in my case wasn't persisted back correctly or actually deserialized correctly with the correct Java types, which actually is there in the schema. So this is a somewhat extension that it becomes schema aware to say, okay, for example, this would be a double, and then your JSON parser needs to parse it correctly. But in this case, as the first approach, there's somewhat a workaround to say, okay, I'm aware of the types that I want to apply, so I then persist them correctly. But you have to be aware of that. And in this case, then I apply this action, and then hopefully it works that I actually undo the action. So if I now already changed my flavor profile, let's try it out to say curl localhost, and this resides under actions undo. and I need to post something with JSON. So I say post please an action ID with the following action ID and then see what's happening. And in this case, well, looks good. Let's see. If I ask my bean again, my bean, then now I have the old status again. So it's now again fruity and floral instead of nutty and floral with the updated percentage. So now I actually undid the action that I performed previously. What's also important, of course, if I go and say, well, actually just delete this bean, so just delete my coffee, and then if I ask for it again, well, then now, of course, it's gone. So it just, disappeared, and actually it's also gone in the in my database. So let's have a look at that. If I just look at all the beans here, it should not be there anymore. And yeah, that's right, my bean doesn't exist anymore. It was here before. But now, if I again apply this undo action, now the different one, then I can make sure that my bean is there again. If I say, okay, now it's here again, I see this information that was there before. Why? Because now I applied all of these changes again. So I recreated the nodes, I recreated the relationship and everything that was there before. Let's update here the query, and there we go. It's there in the database again. And of course, it also contains the correct relationships as you would expect it. So this works. And that is basically how we can implement an undo feature in Neo4j. So this is one approach by using a change data capture approach of persisting that in the graph itself. So this really depends what your use case obviously is in your application. And then also how to use it from the application, that you take this persisted JSON and basically undo it again by reversing it and by applying it to Cypher queries that are actually applied from your application as transactions. So you can take this further, even that you have something like that goes into the direction of event sourcing. If you apply things like that, you can of course emit these type of transactions and events similar to this streaming plugin to Kafka or to something else where it will be stored externally. You could further include some logic that these actions get invalidated after a short time, or that you can only apply the latest ones, and so on and so forth. So that is of course interesting to look at what your use case looks like. You can try out this example again on the same repo of the Quarkus playground and of this plugin that I provided. So this is used, you actually need to enhance your Neo4j instance with this running plugin, and then this example that you can try out. And I hope this was interesting to watch. And now I want to wish you all some happy holidays and a good start into the new year. I hope it was fun to watch, and thanks a lot for watching. Bye.